Hello friends, in this video we are going to talk about a Gauss elimination method with pivoting procedure added to that. So our objective is to solve a system of linear algebraic equations using Gauss elimination method with pivoting. Let the system of linear algebraic equations be as given here. So when we arrange this in a matrix form, A times x equals b, where A is the 3 by 3 matrix and b is the 3 by 1 vector. Our objective is to solve for the unknowns x1, x2 and x3. When you try to solve this equation using the unpivoted version of Gauss elimination, let's see what happens. So in this particular program, this Gauss elimination with no pivoting involved. The A matrix is given here and the B vector is given here. And when you try to solve this using this procedure, it doesn't solve, it could not solve. So it basically kind of crashed. But x1 here represents the MATLAB built-in function which is able to solve this problem. So what is wrong with this procedure here? So we find that there is a 0 in the main diagonal element, the first row and first column. So this is the issue we have when we try to solve using the unpivoted version of the Gauss elimination method. So to avoid this, we have to use the pivoted procedure. So the initial method is given here. The initial set of equations is given here. And then what we need to do is we need to interchange the rows to meet the pivoting guidelines. So for example, in the first column, we have to find the maximum value. So in this case, the second row has the number 4, which is the maximum value in column 1. So we interchange the second row with the first row, and we arrive at the set of equations 1 dash, 2 dash and 3 dash. So we continue the same procedure below the diagonal elements for the next step. So we have to compare the values below the element at 2, 2, that is the second row and the second column. So here we compare. We find that the number 3 in the third row is has a higher value than the number 2 in the second row. So we once again interchange row number 3 with row number 2, and we get the set of equations in given as 1 double dash, 2 double dash and 3 double dash. And this procedure has to be repeated until we reach almost the r minus 1th row, the final row but 1. The set of equations below is now pivoted since it is only a 3 by 3 matrix we have, and 3 sets of equations. So we can solve this equation using MATLAB now. So with pivoting, the same A matrix and B vector is given as before. So we run this So the original AB, the combined matrix is here. Once it is pivoted, we get we rearrange the set of equations in this form, which is like here, 4 minus 2 0 on the first column, 4 minus 2 0. And once it is arranged this in this fashion, we can use the Gauss elimination procedure, which we have used, the simple one. So the pivoting algorithm is given here, and then the forward elimination is given here, and the backward substitution is given here. The forward elimination and the back substitution remains the same, and the values obtained here are -1, 2, and 1, which compare to the built-in the values provided by the built-in function in MATLAB, which is -1, 2, and 1. So, in summary, we presented in this video a procedure to solve a system of linear algebraic equations using Gauss elimination method with pivoting procedure. As we noticed, pivoting helps to solve the problem if zeros are present in the main diagonal elements. In the next video, we can look at other methods to solve a system of linear algebraic equations. If you have any questions, please post it. And thanks for watching the video.